There is perhaps nothing more mysterious in our universe than the existence and details around black holes. While Hollywood has dramatized several scenes involving them, few are actually realistic, and it is actually frightening how little we know about the nature and specifics of these vast expanses of nothingness. While the movies may have convinced you one way or another, what actually happens at the center of a black hole? Today, we're going to detail, based on the latest scientific evidence, what exactly takes place inside the mysterious black holes throughout our massive universe. We'll go over the origins of black holes, their initial discovery by astronomers, and what takes place inside of them. So you may be wondering, what exactly is a black hole? The answer to that question is complex, but the simple answer is that black holes are regions in space that contain a gravitational force that is so strong that not even light can escape its powerful grasp. Anything caught within the pull of a black hole is pulled into a never-ending void where both time and space are distorted beyond human comprehension. In short, a black hole is a never-ending sea of nothingness. At the very center of black holes exists a singularity, a realm beyond current scientific understanding, where matter is actually crushed into virtually nothing, and the concepts of both time and space are utterly lost. It's a domain that defies human explanation and is often referred to as sort of a no man's land. What scientists do know, however, is the sheer power of these holes. For example, if a large star were to orbit too close to a black hole's gravity, it would be torn apart in an instant. The term black hole was first coined by American physicist John Wheeler in the 1960s, and since then, scientists have continued to discover new details and varieties of black holes, including stellar black holes, intermediate black holes, and supermassive black holes. While their mystique may lead you to believe that they are somewhat rare, this actually isn't the case. In fact, it's estimated that our galaxy, the Milky Way, may contain over 100 million black holes by itself. One of the most notable of these, Sagittarius A, is located at the center of the Milky Way and is approximately 4 million times the size of the Sun. Incredibly, it's located just 26,000 light-years away from Earth. Another relatively close black hole was captured by the Event Horizon Telescope in 2019, marking the first image captured of a black hole. The first of its kind image began a new optimism around solving the secrets surrounding the space anomalies. According to the Space Telescope Science Institute, it's estimated that there are roughly 100 million black holes in the Milky Way alone. And while their impressive size may make it seem different, detecting black holes can actually be quite a difficult task. It's thought that there could be anywhere from 10 million to over 1 billion black hole systems in our galaxy. The closest black hole to us has been nicknamed the Unicorn and is located just 1,500 light-years away. There are several forms of black holes, including the smallest type, known as primordial black holes, which can be as small as an atom yet have the mass of a mountain. However, the most common black hole forms are stellar, intermediate, and supermassive. The first that we're going to look at in more detail are stellar black holes. Inevitably, stars of all shapes and sizes eventually burn out and collapse. When this occurs to small stars, their core becomes what is known as a white dwarf. But when a large star burns out and collapses, compression continues to take place and a stellar black hole is the result. These black holes are relatively small in comparison to other forms, but are incredibly dense. Just one of these stellar black holes has over 3 times the mass of the Sun, while being just roughly the diameter of an average-sized city. This leads to an insane amount of gravity, which pulls in objects surrounding the hole. They then consume the various matter from surrounding galaxies, which allows them to continually grow in size. Next on our list are the intermediate black holes. Not so long ago, astronomers agreed that black holes came in only 2 sizes, large and small. But further research and technological advancements have revealed the likelihood that a mid-sized or intermediate black hole could also exist. These holes likely form as a result of clustered stars colliding against each other in various chain reactions. If multiple intermediate black holes end up colliding together, they can also form a supermassive system, which we will cover in just a minute. Then, in 2014, astronomers found the first intermediate black hole located within the arm of a spiral galaxy. Further research from 2018 also backed this up and suggested that these intermediate holes may exist within extremely small galaxies, also known as dwarf galaxies. In observing 10 of these galaxies, astronomers found various X-ray activity, suggesting the presence of black holes that fit the size frame of intermediate black holes. And finally on our list are supermassive black holes. While there are plenty of small black holes throughout the universe, their larger siblings, supermassive black holes, dominate. These gigantic holes are millions or sometimes billions of times larger than the Sun, but are roughly the same in diameter. These black holes predominantly exist at the center of the majority of galaxies, including our own Milky Way. It's thought by many leading astronomers that supermassive black holes are formed as the result of thousands of smaller holes that bind together. Another hypothesis states that gas clouds could also be their origin by collapsing on each other and accumulating mass. A third option that may lead to the formation of supermassive black holes is the collapse of stellar clusters. And there is even another suggestion that supermassive black holes originate from clusters of so-called dark matter. Dark matter in itself is another mystery of space, as we know that it exists, but because it doesn't emit any light, it is unable to be captured on camera to be observed. While we are certain of their existence, scientists disagree on just how these large holes are formed. Once these giants are formed, however, they continue to gather mass from the materials around them, including space gas and dust, both of which are plentiful within the center of galaxies, which eventually leads to their unfathomable size. Now that you know a little background on black holes and the various types of them, what exactly does a black hole look like? Well, black holes are made up of three separate layers: the outer event horizon, the inner event horizon, and the singularity, located at the center of the system. The event horizons are essentially boundaries of sorts, located around the black hole and serve as the hole's point of no return. Once an object crosses the event horizon, it cannot escape the powerful gravitational pull of the black hole. The singularity, located deep within the black holes, are these super dense inner regions of the systems where the bulk of the mass is concentrated. While scientists can't directly observe and study black holes, they can detect them by the way they interact with other objects, as well as the radiation they emit. These interactions and radiation readings have allowed astronomers to decode the existence of both the singularity and the event horizons. Now, you may be asking, how can we know anything for sure about something that is completely invisible to the naked eye? The answer is simple: by observing the effects it has on the objects and energy around it. For example, when a black hole sucks in gas and dust from its surroundings, the material heats up and emits radiation that we can detect. This process is known as accretion. But the truly mystical question on everyone's mind is what happens when something falls into a black hole. Well, according to the theory of general relativity, time and space become warped in the presence of a massive object, such as a black hole. This means that time slows down dramatically the closer you get to an event horizon. And theoretically, if you were to cross that threshold, you would be painfully stretched out to a thin strand of matter. But the mysteries of black holes don't stop there. There are quite a few phenomena that are associated with black holes that are equally as mysterious. One example is the accretion disk. These are disks of material that form around the exterior of a black hole as it sucks in matter from surrounding objects. The powerful gravitational forces of the black hole cause the material in the accretion disk to heat up and emit intense radiation, making it visible to the naked eye and to telescopes. Another phenomenon associated with black holes is the jet. These strong beams of matter and energy are shot out from the accretion disk seemingly at random. The exact process by which jets are formed is not fully known, but it's assumed that the magnetic fields surrounding the black holes play a role in creating these jets. And there are probably millions of other secrets around black holes that are just waiting to be unlocked. And as we continue to study and learn more about these elusive objects, they will continue to captivate and intrigue us. From the sheer warping of time and space to their powerful jets and gravitational waves, there's so much we have yet to learn. So in short, what happens at the center of a black hole is mostly unknown, but we can't wait to see what the coming years of research and further technological advancement will be able to discern about the most mysterious objects in our universe. That's going to do it for today's video. Thanks for watching. If you liked this video, please help us to continue providing similar content by liking and subscribing to our channel, and until next time.